Alright, let's try this again. We're gonna do reflections again. Or not again, but for today. So, a reflection is when you take a shape and you're going to flip that shape over a line, and it's going to be called, that line is called the line.
Why does it say a flip over?
Because that's what a reflection is. And you're going to flip it over the line. The line is called the line of reflection. Okay. And each point in its image, so remember the image is what it is after you moved it. That would be your, or they should have the same distance away from each other. Yes. Like when you look at the picture, so you see how the axis right here, how far away is B right here?
3.
How far away is this B?
3.
So is the other the exact same? Same distance. Same thing with C and C prime. C is how far away? And C prime is 1. That's what it means by the same distance away from the line of reflection. Okay? It's the same thing. I mean, you can count it. So A should be what? 4. And A prime is 4. So that's how you know. And a reflection is another example of a rigid motion, which is what we talked about yesterday. Remember, a rigid motion is when the size of the shape does not change. So the size stays the exact same. What, Thorsten? Yes. All right. So, in reflections, the most common lines of reflection that you're going to have are going to be your axes. So the x-axis and the y-axis. They also might use some of like the x equals a number or the y equals a number. Those are your 4 most common. Okay, remember, if it's an x equals, is that horizontal or vertical? These are your vertical. And a y equals is horizontal. Okay. There's only 2 types of diagonal lines they're going to give you. And it's going to be when y equals x and when y equals negative x. Okay. So if y equals x, do you think that's going to be a positive slope or a negative slope? Positive. So essentially it's going to look like this. It's going to be going up to the right. And if it's a y equals negative x, what do we think? Down. Okay, so it's a negative slope. It's going down to the right. Wyatt?
May I use the bathroom?
After the notes.
Okay.
Thanks. You finished both pages, front and back.
Oh, no.
So I thought. Alright, so we're gonna practice a couple and then we're gonna try the harder problems. Yay! It's gonna be fun. Alright, so let's see. Same as yesterday. Did they give you the shape on the graph? No, so you gotta graph the original shape, please. So let's start with a triangle. So you have triangle ABC. Let's see. 1, 2, 3, 4. 1, 2. Gabe, are you graphing?
Oh, yeah.
No, you're not. So you should have a triangle kind of like this, right? And then what did they say we're going to reflect our shape over?
X-axis.
Where's the x-axis?
Horizontal.
The horizontal, okay. So I like to highlight it so I know what I'm flipping it over. So if you have your own highlighter, you can, or you can just like color it over it, or just like something so you can kind of see it. Now, the easiest way to do it, just count. So again, from the x-axis, how far away is A?
2.
It's 2 what? 2 up or 2 down?
2 down.
2 up. So A is 2 up. So to reflect it, now you're gonna go
2 down.
2 down. And that's gonna be A prime. So you're just gonna count. That's the easiest way to do these. So same for C. If C is how many far up?
1.
So now you're gonna go how many down?
1.
There you go. Now B's the fun one.
7.
Yep. So it's 7 up. So now we're gonna go
7 down.
7 down.
So you're just like,
The Y then.
So the X value does not change.
We're just changing the line.
Yep.
Times the line.
So times the Y by what?
-1.
Correct. So that is the rule for this one. If it's an x-axis, the rule is you keep the x, but you flip the y, or it's the inverse of y. So
Tears popped up, and like something popped up, and like I looked away at 1 second.
okay, it doesn't say you're locked out. Alright, and now we have to list the points. So again, you can either look at it on the graph or use the rule that Pearl was talking about. Either way works. But no matter what, everybody should get what for A prime?
-2.
Good. What about C prime?
5, -1.
5, -1. And then B prime?
4, -7.
Good. Alright. Alright. Makes sense so far? Okay, so we did an x-axis. Now let's do a y-axis. So, Anderson, do you want to do a rectangle or do you want to do a trapezoid? Trapezoid, alright. So let's do a trapezoid. Yep. So again, is the trapezoid on your graph? No, so put it on your graph. So everybody should be graphing number 3, please. Thank you, Joseph. So I got something kind of like that.
What?
That's what mine looks like.
Those mine.
Yours should look similar, hopefully. And what are we reflecting over this time?
Wow.
Which one's the y-axis? The vertical. Again, it should be this guy. So again, if highlighting it helps you, please do that on your homework, especially if you're one of my visual people. Hey, now this time, our shape is on the left side, right? So when I flip it over, okay, it should look like this. It should flip over like that. Okay. So which point is not gonna move? H. Why? It's already on.
The Y-axis.
It's on the y-axis, so it's not gonna move.
What if the shape like intersects the axis?
then like if it intersected, then the top part would go over and the bottom would go over. So it would just flip like that. Yeah. But which part are you going to multiply by a -1 this time, Pearl? The x values. Alright. So again, it should look kind of like that. And again, either using the graph or using what Pearl said for your coordinates. If you're flipping over the y-axis, you should be flipping which value?
X.
So the rule for a y-axis is -x, comma, y. So what is f prime at?
It's 5 and -2.
Yep. So 5 and -2. What about g prime?
2, -2.
0, -6.
H prime?
0, -6.
Yep, that one doesn't change. And then I prime.
It's 8, -6.
Good. Alright, makes sense so far with how to do the y-axis and the x-axis ones?
Yes, ma'am.
Okay, now we get to do the other super fun ones. Okay, so now we're going to reflect on other vertical and horizontal lines. So this is the x equals and the y equals. Okay. Alright, so for an x equals, let's see, I'm going to let Colette pick. Colette, do you want to do a triangle or a square? Triangle? Alright, so we're going to do a triangle. So for our triangle, again, did they already graph it for you? No, you gotta graph it. And you should get a little itty bitty triangle like that. Right? Yeah. Okay.
Yes.
Alright, now what does it say we are flipping it over this time?
X equals 4.
Where's that?
Diagonal.
It's not diagonal.
Up and down. Or that's right. Up and down.
On the right side at the 4.
So right side, so 1, 2, 3, 4. So that would be here, right? So we should have a vertical line.
Oh, you flip it over.
Yep. So we're gonna flip it over that.
Mm.
Okay. What I said. Okay.
Should I put a line on the X equals?
I would.
I'm gonna put a line.
So please, if it doesn't already have the line of reflection, please draw the line of reflection. It can't hurt you.
I do the line. I'll also do the line.
Good.
Thank you.
And then we're gonna flip it over that. Anderson, enough. Doesn't matter, you should be graphing. Thank you. So it should look kind of like that-ish. Right?
Does this mean that then we would multiply the y by -1? Or the
No.
x by
Neither.
You said something like 4.
You have to move it 4 and then flip it.
So you add?
Mm-hmm.
You add 4.
Well, like if you look at K for example, okay? So K starts off at what, 2 and 3? And now it's where? 6 and 3. Okay? So we had to do what to the 2?
You have to
Uh-huh.
add 4 to the X.
Okay? Now, does adding 4 work for every point though? No. Like for L prime, what's the new coordinate now?
It's
5, negative 2. So does that one have like a rule? No. So these ones, there's no like cheat way to figure out the coordinates other than looking at the graph. I mean, I'd like, there is a way, but it's a lot longer. Just look at the graph, it's easier.
Couldn't I do this one?
Yeah, probably. What about J prime? And I still need that one.
7, negative 1.
7, negative 1. Where do you get 3, Mason?
I think it's
Are you looking at L? Okay, that's what I thought. Alright, so we did an x equals. Guess what we're gonna do now? A y equals. But I'm gonna let FA pick. I was actually gonna call on you too. FA, do you want a parallelogram or a triangle? Why are y'all picking the triangles? Oh, because it's shorter. Alright. Alright, so again, did they already give you the triangle on the graph? No. So go ahead, graph it yourself.
What if it's like a
Lucas,
square?
graph please.
What if it's like a square and then like they tell you to do the thing, but it's right in the middle of the square?
Okay,
Then what do you do?
you'll see.
That means it will happen.
Essentially what would happen is like, so here, like if your square was like this bottom part would flip here and this part would flip there.
No, but I mean like what if it was like up and down like in the middle of it? Like,
Yeah, so again, same thing. So like this part flips over here and this part would flip over here.
So it would look the same?
Eh, like if it was a square, yeah. But if it's a triangle, no.
what if it's a exact?
Then it should look the same depending on how it was flipped. Like if it was like a triangle like this, and if the line of reflection was through the top point here, then yeah, it would look identical.
But
So yeah.
That's a funky looking triangle.
This is a really little one.
I would say it's really good. It's pretty low. It's not really funky.
This is a really little one. Alright, and what are we flipping this over?
X-axis, aka.
Y equals. Okay, so on your y-axis, find negative 5. So there's negative 5, and then we're going to draw a line through that. So first, it should be a horizontal line this time. So this time, our shape is under it, right? So when we flip it, now it's going to be
Above it.
above it. It's going to go over that line. So let's see. Again, we're just going to be counting. So M. How far away is M?
3 units.
So instead of 3 down, now you're going to go 3 up.
Up 3 units.
It isn't that bad.
And N was only 1 away.
So you go up 1 unit.
Yep. And P is,
3 units down. So you go up 3
yep.
units.
And then again, unfortunately, this one doesn't really have a rule you can follow. Okay. So again, just reading the graph and looking at the points is going to be the easiest way to figure them out. So what is M prime?
-6, -2.
Good. All right, what about N?
Wait, -1, -4. -2?
Yeah,
Why is it -2?
Look.
If you're moving up 5.
because we were at,
So just
you,
count.
no, no, so it's, we moved up 6. 1, 2, 3, 4, 5, 6.
Got it.
So -8 moved up 6 is -2. All right, what about N prime? What's that one?
-1, -4.
Okay. What about P prime?
-2, -2.
Good.
Like 2 and 8.
Yeah, so if you can count the difference, you can use that. So same thing like with P. P should have a difference of 6. So it's, what, -8 plus 6? So -2. N is the only oddball. That one's only a 2 difference. So -6 plus 2 is the -4. So they don't all follow the same rule. But you can still use that logic to help them. All right, now we get to do the weird lines. So these lines are what? Are these horizontal and vertical? No, they're diagonal. But first we need shapes, okay? We need shapes first. So let's see. Sophia, do you want a triangle or a rectangle? Triangle? What is with y'all and triangles?
There's only 2 points. It's the triangle.
Lame.
What?
All right, do number 9.
Y'all are still yapping. I would have already been done.
That looks like a right triangle. Is that a right triangle?
If it was a right triangle, 2 of the points would have the same y values.
Can it be a right triangle without
It looks like
doing
if
that?
you wanted
Like
to.
it could be like that. Right click.
You would have to be able to do Pythagorean theorem with the sides.
See, with like that. And then like,
I understand what you're saying, Jackson. I'm still saying you would have to prove it with, you'd have to find the distance of each side and then use that to do Pythagorean theorem. Yeah.
I did it out.
All right, now, what's the line we're using here?
Diagonal.
Diagonal positive.
Y equals what?
X.
Okay, so when I say a positive diagonal, if you start at 0, you're gonna go up 1, right 1. And then keep going up 1, right 1. So if you want, you can use your straight edge, your ruler, compass, or ruler, protractor, whatever you're using, and draw a line.
That's good.
It should look like that.
Of
course, you know, I'll
on the
connect
other side of that one.
Yep.
You have to draw it on it.
No.
Okay, so it'd be down to right.
Now, these are where it gets weird, okay? Because either you would need to turn your paper and go diagonally across, which that can be a little more difficult, or Miss Howell likes to make rectangles, okay? I like to make rectangles. When I say make a rectangle, I mean pick a point on the graph. So like from here, see how for X, how it's left 1 up 2? I'm gonna do the opposite. I'm gonna go, or instead of going 1 and 2, I'm gonna go 1 and 2.
Yo, what?
Hang on, I'm gonna write it.
Yo.
So I went, so again, if you turn your paper sideways, it'll help make a little more sense. I made this path, right? I did,
Isn't that just the square?
whoop, hang on, I started at the wrong point. So I did 1 and 2. So I'm making a W essentially. 1 and 2. I made a W.
Does that remind you?
Because it's 1 and 2. 1 and 2. You remember you have to do the same distance. So you can do the same thing with Z. Okay?
Does that remind you of anybody?
Huh?
Why'd you move 2 instead of 1?
Because 1 and 1 wouldn't get me there. It doesn't reach the X value or the X point. You have to move 2.
You swap the X and the left letter?
Okay? It's like this is where Z should be. Okay? The Y one, it's whichever one you can follow along, just to make it easy. I just like to make M's and W's. So 3 and 3.
I had 3.
That's how I do it.
Literally copied.
Okay, now, if you haven't heard Thorsten, okay? If you haven't heard Thorsten, what's the pattern here?
You could just
You can swap the x and the y coordinates.
Okay, that makes it so much more easy.
Yep.
Does that always work?
Yep. For a y equals x, yes.
What about x equals y? Y equals negative x. No.
It's a little bit different.
Oh, wait, I get it.
Yeah. They're asking about when y equals negative x, though. Okay. All right, so that means that x prime should be at what?
-2.
Good. What about y prime?
4, negative 3.
For 11 and 12, we can do both of those.
No. Because I want to do a square and a
And then z prime?
I think we should do it in class.
What was z prime on?
Z prime was 1, -1.
Thank you.
Miss L, can we do 11 and 12? It's like, you gotta do
Go ahead. We're first.
No.
It's me, y, and you.
Okay. Next page. Now we're gonna do some y equal negative x's.
We should do 11 and 12.
Wyatt, enough. You don't have to keep saying the same thing over and over and over. We heard you.
Miss Howell, I think we're good.
No, you're not.
Can we do it
Nah,
now?
I don't think so. Alright, now. Let's see. Thorsten figured out the pattern of you just flip the x and the y when it's y equals x. But do you think that's going to work for y equals negative x?
Yeah.
You go opposite reciprocal.
You're close.
Opposite reciprocal.
You flip it and you make a negative.
Flip what specifically?
You flip the one of the coordinates.
Uh-huh. So you're gonna flip both actually. So it's going to be negative y, negative x.
Oh.
Okay? That's gonna be the rule this time. Again, you can still try to do it with the graph. I know it's a little bit harder, but you can do it that way. And we're gonna do the square because Miss Howell's writing on the square. Let's see, so let's start with our shape, -1 and 3. And 0 and 6. B. And C. And D. What do you mean, what am I doing? Oh. So you should have a little baby square.
It's a square.
Now, if enough. So if y equals x,
It's this way.
Square.
Square.
oh no.
Wait, I thought it went the other way.
Hmm?
Doesn't it go like down right, like that? What just happened?
Go ahead, graph.
Are we ready? Are we doing it myself?
You should be able to. Besides, some of you just want to keep making random comments for no reason and want to disrupt. So go ahead, do the rest. You what? Flip the coordinate. Take -1 and 3. Flip it. What would it say? -3 what? There you go. So what should B prime say?
It should be 6, 0,
No.
-6.
Negative
Better.
6, 0.
C prime? -5, -3. D prime. Better.
Over now. Yeah, flip the coordinates. Well, if it's 1 and 3, or negative 1 and 3, negative. In college, you get the protractor or a compass.
Okay. So the rest of your notes is just identifying what types or what line of reflection it was. So you should be able to just look at it and tell me what it was reflected over. So like number 13, y-axis, good. Okay, 14,
X equals Y,
no.
or Y equals X.
Y equals negative x,
Wait, what?
because it's flipped through this.
Oh, okay. Oh, yeah. Never mind.
Okay.
X equals -3.
X equals negative 3, good. Okay, so again, should be here-ish.
X-axis.
So what's 16?
X-axis.
Good.
That was mine.
17 and y equals 1.
Y equals 1, good.
And
That would be
y
this.
equals X.
And this one is y equals x. Good.
Are we done with the next now?
Okay. Now, if you're not sure, a lot of these types of questions, like if you have the graph, you could try to fold it to see which way is the reflection. That might help you. Okay. And now you get homework.
Yay.